After the electric car got crashed, we just scrapped it out, but I kept the batteries. So what I'm doing is I'm making a power cord. It's actually made of some 2x4s here, just screwed together in a rigid fashion. Go to Harbour Freight and get 4 of those little wheels. They only cost $3.99 each. That's great. The casters too, so they're multi-directional, and they also have a brake on them there, which is great. So what we're going to do is we're going to join all these batteries up in parallel, so we'll get 12 volts. They're all 12 volt batteries, and then connected onto an inverter. Not this one though. We need to make some wires to join each battery together. So how that was done, I just got some 1/0 wire here. Actually that's number 2. And got some long piece of copper pipe that looks a lot like this. Jammed the end in the vise and cut it off. See, jam like that, and then you're left with a hole. And what you can do then is you drill a hole through that end and put it on each end of these jumper cables. I'll call them jumpers, which is what they are. And then once they're on there, they can be soldered onto the lug. The wire can be soldered onto the lug there. So that's the plan for today. So I'm just in the process of putting the lugs onto the wires with solder and drilling some holes. The conductor itself, and I nipped it in the vise so it's a nice tight crimp. Then drill a hole out there so that fits over the battery terminal. So that should be good. Only thing is, when you're heating these terminals up, you tend to melt the insulation there, so I think I might just put a wrap of tape around there just to make it look better. And then once that's done, you take you put it on the grinder to grind the edges down here so you don't end up with a sharp edge. Then just take some wire wool and shine it up. Not only does it look good, but it makes it good for a good contact on the battery, which is of paramount importance, I believe. So it looks something like that. Not too bad, not too bad. So I'm going to put this on. I'll show you what happens next once you get these guys all cleaned up and put on the batteries. Okay, so now we're going to put these jumper cables on the terminals. I'm putting them on in like a kind of an S configuration. They'll fit on much easier. So these 5 batteries are all connected in parallel. Each battery is 12 volts, and the way they're connected up is that only put out 12 volts at the end of the circuit, and this is how it's done. The negative of this battery is connected to the negative of that one, to the negative, 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 and on the last negative you go to your negative on the inverter. This inverter is 120 volt output with 12 volts DC going into it. That's the reason I've connected these batteries like this, so that we end up with 12 volts going in and 120 volts coming out. So that's what you call a parallel setup. Now on the other inverter cart, we have an inverter that puts out not only 120 volts but puts out 240 volts. Would that run your washing machine? It might do, I don't know. But this has a 24 volt input. So to get 24 volts from a 12 volt battery system is you have 3 batteries there, 3 batteries here. Now on the last diagram you would normally connect that to that, but to get 24 volts you have to take a jumper from this negative to that positive. Right, so that's how that works. And then you take a jumper from this positive all the way out to your inverter. So the potential difference between this line and that line, or the voltage between the 2 lines, is 24 volts. So that's exactly what you need to run this inverter. Okay, so it's all connected up, the batteries with the inverter. This is a 1500 watt fan plugged into the 2000 watt inverter. We'll see if it works. Well, the fan part works. We'll turn on to, okay, there's 750 watts there. And now it's on high. Okay, so there's 1500 watts there, and it seems to be working real well. Alright, good. So you can plug in your household appliances to this inverter. Okay, so this is the guys all hooked up, and that seems that is working well by the looks of it. I'm pleased about that. And it does have an on-off switch, so it is using a little bit of power even when it's off. And this is the latest one we just put together, so we've got plenty of backup power right now. Well, thanks for watching this. I hope you enjoyed it. This is going to be just like a backup power supply, because every so often, you know, in the winter especially, you lose power, so it'd be nice to have lights. And thanks for watching. Bye bye.